Hi guys, welcome back to another video. Today we're going to be solving week 6 chemistry AMS. So let's begin. First question, which of the following electron configurations correspond to noble gases? So first of all, let's look at our periodic table and locate where noble gases are found. Noble gases are found, as we can see, in group 8. And what is special about noble gases is that they are very stable, they are inert, so they are unreactive. So if we want to check their electron configuration using this method, okay, not the 1s2 2s2 method. So let's look. If we start with helium, it's just going to be 2. If I go to neon, it will be 2 8. If I go to argon, it will be 2 8 8, because 8 plus 8 is 16, plus 2 I get 18, and then so on. Okay, so let's just check our options. We have 2 8, yep, which is neon, and we have 288, which is argon. Let's go next. 3.73 grams of an organic compound X were analyzed and found to occupy 0.8 decimeters cubed at 27 degrees Celsius and 2 atm. They're asking for the molecular mass. So first step, what I will do is I will write my given. So what is my given? Let's just go back. So the pressure was 2 atm, volume was 0.80 decimeters cubed. I have 3.73 grams, so mass is 3.73, and the temperature is 27 degrees Celsius. So what I would usually do is before I write 27 degrees Celsius, but I will directly convert it to Kelvin, which I just add 273, so it will be 300 Kelvin. And what they're asking for is the molecular mass. Okay, this is the first step I would do. Then I would put the equations that I know. So what equation can I use here? I can use PV equals to nRT. Now I can solve this question either in one step or in two steps. So if I want to solve it in two steps, I will first find the number of moles, and then I know that N is equal to mass over molar mass. Or from the beginning, I will, instead of writing N, I will put mass over molar mass, or T. Then what am I going to do? Just substitute. So 2 times 0.8 equals to 3.73 over M. The constant is going to be 0.08 times 300. Why 300? Because temperature has to be in Kelvin. Then I will just solve it, and I will get the molar mass to be 56. You'll get 55.9, and then just round it up, you will get 56. Okay? Or you can just, instead of substituting directly M over molar mass, find the number of moles first, and then do this as a second equation. Okay, the empirical formula of a compound X is CH2O. So directly, I'm going to write on my scratch paper CH2O. Okay? Empirical formula means the simplest form. If the molar mass of the compound is 60 grams per mole, so I will directly write molar mass is 60 grams per mole. What is its molecular formula? Okay, so I want to find the molecular formula. This is very simple. Since I have the total molar mass, what am I going to do? I know that the molar mass of carbon is 12 times X plus 2X plus, because for hydrogen, plus 16X equals to 60. Then I will find X to be 2. So my molecular formula will be C2H4O2. A student wanted to find the maximum mass of aluminum oxide produced when a sample of 0.80 moles of aluminum reacts with excess oxygen gas. So here they're already telling us we always, when we're solving, we never use the excess amount, we use the limiting amount. The chemical equation of the reaction that takes place is represented below. So first I will copy the chemical equation. So I have 4 aluminum plus 3O2, which is gas, gives me 2Al2O3. Now here the equation is already balanced. However, in the exam, watch out if the equation is not balanced. Always double check that your equation is balanced. So this is the first step. I want to find the maximum mass of aluminum oxide. So I used 0.80 mole, as you can see here, 0.80 mole of aluminum. So I'm gonna put first the given, which is 4 moles of aluminum, gives us 2 moles. Okay, now we're reacting 0.8 will give us how many moles? So I will cross multiply, I will get 0.4 moles. However, am I done? Of course not, because they're asking for the mass. So I will write N equals to mass over molar mass. So the mass is N times the molar mass. So 0.4 times the molar mass of aluminum oxide is going to be 102. So the answer is 40.8 grams. And since they said 3 significant figures, it will remain 40.8. Let's say they said 4 significant figures. 4 significant figures would just be 40.80. Okay? A hydrocarbon is 75% carbon by mass. Find its simplest formula. So this question, we can solve it in several different ways. I will solve it in this way. So since carbon is 75%, so hydrogen will be 25%. Why? Because since it's a hydrocarbon, so I only have hydrogen and carbon. And of course, they should add up to 100%. Next, what I will do is I will divide by the molar mass. So 75 divided by 12 and 25 divided by 1. Okay, I want to find the ratio of carbon to hydrogen. 75 divided by 12, I'll get 6.25. And here I will get 25. But I can't have 6.25 carbons. I need a whole number. So I will divide by the smallest number, which is 6.25. Divided by 6.25, I will get 1 to 4. So my ratio of carbon to hydrogen is 1 to 4. So CH4 will be my answer. Okay, again, you don't need to read the question, directly look at the formula. And I'm going to copy the formula. So 2H2 plus CO gives us CH3OH. And again, the first step I'm going to do is check if my equation is balanced. So I have 4 hydrogens, I have 4 hydrogens, I have 1 oxygen, 1 oxygen, 1 carbon, 1 carbon. Okay, perfect. When 0.50 tons of H2 react completely with CO gas, the amount of methanol produced with 3 tons. Calculate the theoretical yield, and then we want the percentage yield. So first I'm going to put my formula. What is my formula? My formula is percentage. Okay, wait. Percentage or percent yield is going to be what? Actual yield over theoretical yield times 100. Okay? Now the theoretical is what I will find. The actual is what they gave me already. Okay? So let's look at it. 0.50 tons of H2. So first I'm going to put 2 moles, or not moles, sorry. We're going to put the mass. Since we're talking about tons, it will be the mass. So the mass of hydrogen will be 4, okay, because 2 times 2. And the mass of CH3OH will be 32. if you want to see how we solve it, 12 plus 1, plus 3 plus 16 plus 1. Okay? Then 0.5 tons will give me how much? This is going to be my theoretical. My actual was already given when they told us 0.50 tons gave us, how much was it? 3 tons of methanol. Okay? Now here we just cross multiply. Once we cross multiply, we will get x to be 4. Then I'll just follow this formula. So 3 over 4 times 100, I will get 75%. So the theoretical yield was 4.0 tons since it had two significant figures, and then percentage yields also 75%, two significant figures. Write the electron configuration of a boron atom. So first, of course, I'm not going to take the 11, I'm going to take the 5. Okay? Then, to write the electron configuration, always write this on your scratch paper. 1s2, and then 2s2, 2p6, 3s2, 3p6, 3d10, and you can continue 4s2, 4p6, 4d10, 4f14, and so on. And then you put the arrows. So since we need 5, okay, so I'll write 1s2, then 2s2, then I only need one more, so it will be 2p1. And that is my answer. Now you can also find the electron configuration just by looking at the periodic table. Okay, I lost where the periodic table is. Okay, so we can get it just by looking at the periodic table. So if you want to learn how we can get the electron configuration just by looking at the periodic table, let me know in the comments down below and I'll make a video about it. Okay, now let's get back to our questions. Okay. 1 mole of hydrogen reacts with 0.25 mole of oxygen to produce H2O. Which reactant is in excess? Okay, so whenever you have a limiting and excess question, it's super simple. Look what you do. Again, we're gonna write the formula. Make sure you always write down your formula and check that it is balanced. So 2H2 plus O2 gives us 2H2O. First, I'm gonna start with the hydrogen by itself. So I'm gonna write the equation twice. Okay. And I'm just gonna focus here on hydrogen and then here on oxygen. So first I write the given. So 2 moles, 2 moles. Gives us 2 moles, 2 moles. Now they're asking for 1 mole of H2. So 1 mole will give me how many moles? You already can see the ratio, it's 1 to 1. So it will give me also 1 mole of H2O. Now we have to check the oxygen. Again, 1 mole of oxygen, 2 moles, then 0.25. How many moles? We cross multiply, we will get 0.5 moles. So of course, the oxygen is limiting, while the hydrogen is excess. They said the excess, so we're gonna say the hydrogen. Okay, so since we have oxide ion, which is O2 minus, so whenever you have an anion, you just add the number to its total. So oxygen has an atomic number of 8. Since it's 2 minus, instead of 8, I'm going to put 8 plus 2. Okay, so it will be 10. Again, if I follow the 1s2, 2s2, it will be 1s2, 2s2, which is 4 now, then 2p6. Now here we have a sodium ion will be what? Na+, and it is a cation. Now cations, we do their electron configuration in a different way. We're gonna do it normally first. So for cation, do it normally. That's your first step. Then second step, remove electron from outermost shell. Now, how many electrons will I remove? Depends. If it's plus 1, I'll remove 1 electron. Plus 2, I'll remove 2 electrons. Plus 3, I'll remove 3 electrons. And you always remove them from the outermost shell. So since we have sodium, which is 11, so first I'm going to do it normally. Okay? 1s2, 2s2, 2p6, then 3s1. However, sodium is what? Is Na plus. So I need to remove 1 electron, which is the outermost electron. It will be this one, and only has 1 electron. So once I remove it, I'm left with 1s2, 2s2, 2p6, and that is my answer. Okay, so sodium has an atomic number of 11. Here, since we're not asking for sodium as an ion, just sodium normally, okay, we don't need to remove any electron. By referring to the electron configuration in part 1, choose the group and period to which sodium belongs. Now, group number is determined by number of valence electrons. What are the valence electrons? They are the electrons found in the outermost shell. Okay? While period number will be the highest n. Okay? Very simple. So we look at the outermost shell, it's 3. How many electrons does it have? 1. So it is group 1. And then for the period number, we look at the highest n, okay, which is 3. So it is period 3. Okay. So they're asking us for the valence electrons. Remember, I just said the valence electrons are the electrons found in the outermost shell. So it's going to be not 2, it's going to be 4. And we can also know that because carbon is in group 4, so it has 4 valence electrons. Okay, this is also easy. So let's put the ratios we have. 0.96 mole hydrogen, 0.24 mole for carbon, and 0.48 for oxygen. Remember when we divided in the question for the empirical formula, we divided by the smallest ratio, which was 6.25. Here we're going to do the same thing. We're going to divide by the smallest ratio, which will be 0.24. So 0.96 divided by 0.24 will be 4. This is for hydrogen. For carbon, 0.24 divided by 0.24 will be 1. And then for oxygen, 0.48 divided by 0.24 will be 2 for oxygen. So my formula is going to be CH4O2. Oxygen has an atomic number of 8. This is straightforward. Electron configuration, it will be 2, 6. Okay, so whenever you have such a question, volume and concentration, directly write on your scratch paper CV equals to CV. However, here you're going to have to read the question properly. If we take 60 milliliters, so my volume is 60, out of a 0.4, so my concentration is 0.4, and added to 140 milliliters of distilled water. Now the volume, will it be 140 or will it be 200? Of course it's going to be 200. Why? Because I'm adding the 60 to 140, so it's always going to be the total volume. V2 will be the total volume. Watch out from this mistake. Then you're just going to divide by 200 to find the concentration. C will be equal to 0.12. Okay, again, first thing I'm going to do is directly copy the equation down on my scratch paper, just so I can avoid any silly mistakes. And I will check if the equation is balanced. Here it is balanced. Now let's check the question. Okay. How many grams of CO are produced? Give your answer to three significant figures. So this is, first one is straightforward. We have 20 grams of CaCO3, which is calcium carbonate. So we have 20 grams. I want to check. 1 second. Okay. So we have 20 grams. And we want to find how many grams. Now, this will be 100. This is given. Okay. And 56. Once I cross multiply, I will find my x to be 11.2 grams. And this is the three significant figures. Now, what volume is at STP? So this is, pay attention to it. STP means the volume is 22.4. Now, if they said RTP, it will be 24. Again, very straightforward. I'm going to use 100 grams. Okay, this is just the molar mass of CaCO3, calcium carbonate. Gives me the volume will be 22.4 because it's at STP. Now, 20 grams, how much will the volume be? Cross multiply again, I will get 4.48. Okay, again, I'm going to copy the equation. Always copy the equation on your scratch paper. Fe2O3 plus 3CO gives us 2Fe plus 3CO2. Again, always check if your equation is balanced. I have 2 iron, 4 oxygen, no, 6 oxygen, and 3 carbon. Perfect. They want the mass to produce 90.5 kilojoules. Now, I already know I'm producing 18.1 kilojoules. And what is the mass? It's going to be 160. It's given already. So I will write 160 giving 18.1. So how much I need to release? 90.5. Again, cross multiply. My answer will be 800 grams. This is for part 1. Part 2, what volume at RTP? Remember we said RTP, the volume will be 24. And again, straightforward, 160. But watch out, I'm not going to just put 24 because I have 3 moles of CO2. So 3 times 24 and 800 grams to get 90.5. I got it from part 1. The volume, cross multiply, it will be 360. Again, first thing, I'm directly going to copy my equation. So F2 plus KCl plus 2 KCl gives me 2 FCl plus Cl2. Again, check if my equation is balanced, and it is balanced. How many moles of KCl are required to produce 14.2 grams of Cl2? So I need 2 moles of KCl gives me 71 grams. I need to know how many moles to give me 14.2. Cross multiply again. My answer will be 0.400 moles. How many grams of Cl2 are produced from 0.3 mole of F2? So I have 1 mole of F2 gives me 71 grams of chlorine. And they're asking 0.3 moles will give me how many grams? Again, simply cross multiply, and my answer will be 21.3 grams. Again, first thing I'm going to do, write the equation. All the questions are very repetitive and they're all the same concept, okay? So P406 plus 202 gives me P4010. Is it balanced? First thing I check, I figure out it is balanced, so I can move on. They're asking me the limiting reagent or the excess. Okay, we want to find which is limiting, which is excess. Again, you can write the equation twice, and each one you're gonna check a different reactant. Okay, so in the first one, I'm gonna check P406 if it's limiting or excess, and then the second one, I will check oxygen. So they already gave me the mass of P406 to 220. This is given, gives me 284. In the question, they told me 5.5, so 5.5. I need to find it. I cross multiply, I will get 7.1. Now for oxygen, it's going to be 64 to 284, then 20 to how much? Now I don't even need to solve it, but let's just solve it to double check. I'll get 88.75. So of course, this is going to be my limiting, while this will be my excess. So the limiting reagent, okay, and the mass are refounded. Since they said 3 significant figures, I'm gonna put 7.10. And that is it for this week's quiz. It's very straightforward. My only tip is write the equation, make sure it is balanced, and be very organized in the way you solve it. And I'm sure you will get easy grades. It will be super easy for you. Thank you all for watching. I hope this was beneficial. Don't forget to like, comment, and subscribe. And if you have any questions, let me know in the comments down below. And also, I'm going to in the comments, I'm gonna put a link for a WhatsApp group. If you guys want to join it, you're more than welcome to join. It's just a group where if you have any questions, you can send, and hopefully I'll be able to help you. Thank you all again, and see you soon.